So now that we have an idea of how we want to conceptualize data as it relates to our business or domain model, talking in our case about building a database for a library system, let's start to explore in more granular details how we go from that conceptual model of, hey, we've got books and people, and how do we relate all of these elements together. So let's kind of go back and start at the beginning again. Let's start back with the book. So with the book, we have all these properties. And the way that this is going to work is that we'll take this book, and this book will become our table. We'll have a table of books. And then each one of these properties will be something that describes or becomes the data for the book. Those will become our columns in our database table. And we're going to go through a series of iterations, so don't expect that what we come up with the first time is going to be the right thing the first time. I'm actually taking you through my process personally, as well as the process that you'll find documented in the textbook about how you go through the process of building and defining tables. So for me, I start at the conceptual level. I kind of, in my mind, I build this kind of cloud of descriptors for an element or for an object. And then I say, okay, now I need to translate this into a table. So for me, I usually go in this direction of saying, well, these properties or attributes or elements are my columns. So I kind of take them and move them into that table, and the descriptors that I'm using for column, data type, and required don't match up exactly with what you see inside of SQL Server when you're building out your database table, but I'm going to continue to work toward getting there. But this is at least kind of a starting point, and we'll kind of evolve through it. Alright, so we have different columns. We have ID, title, author, ISBN, page count, Dewey Decimal, publisher, topics, and copyright. And the idea is that those will eventually translate into what would be the columns across the top of our table, and then we would have rows of data populating our table. So we'll get to this part a little bit later. But this, if you need something to kind of say, where's my end goal, where am I trying to get to, it's eventually to have a database table for this first kind of iteration that looks something like this. We're taking that data and we're actually creating columns for those elements, and then we're going to be able to fill in our table with rows of data. Alright, so the first thing that we have in our table is an ID column, and that is there to serve as our primary key. So the primary key should be unique for each row. Typically it's a piece of data that doesn't change. It should be something that's static and referenceable, and it should be relatively short and easy to type in. So integers or numbers are usually pretty good primary keys. If there's other elements of data that can be used as a primary key kind of naturally through the information, sometimes you'll hear people say things like social security numbers are a good number because everyone has their own, except for when they run out of numbers and then they start handing them out again. So you end up kind of running into these things of, well, that makes sense, kind of maybe within your limited scope of understanding, but as you maybe dig deeper into the topic of what you're building your database on, you'll realize, oh, that actually isn't true. So I often find that just creating an ID column and setting it as an integer and making that my primary key in my tables, you're almost guaranteed to have a unique row number every time. You don't have to worry about duplication because it's iterating or adding 1 to that number every time a new row is inserted, and it always maintains a unique value. You can obviously find a data point that you want to use as a primary key, but my recommendation is, unless you know for an absolute certainty that value, that column, is not going to be changed in any way and it's not going to be duplicated, slapping an ID column into a table is not a bad idea. And that primary key field becomes vitally important because then it links back to the foreign key when you're doing your joins. And we'll talk more about primary key and foreign key relationships and joins in a later video. So we now have our identifier. This is our row ID for this table. The next pieces of data are kind of the informational data that we would need. So going back to kind of our conceptual model, we have title, we have author, ISBN, page count, Dewey Decimal, publisher, topics, and copyright. And each one of those has kind of a almost intuitive data type that you would use. So titles are strings of text, so you would use a string or some sort of character type data type. Authors, very much at this point the same way. We're using the author's name, so we would want to put that in as a string. ISBN numbers are typically numbers, but there's a potential that they could be alphanumeric or have additional characters stored within them, such as dashes or hyphens. So I'm choosing to use a string just because I honestly don't know what I don't know about ISBN numbers, so I don't know the potential for that to be something else. Page count is pretty simple. You can only have positive whole pages. So page count is an integer. Dewey Decimal, again, I don't know what I don't know about Dewey Decimal, so I've gone ahead and made those a string. The publisher is the name of the publisher, so again, it's a string. Topics at this point, I'm not really sure what I'm doing with topics, but I know that that's something I need to capture, so I'm making that a string as well. And in some ways, the string kind of becomes a good catch-all. If you don't know what the data type is, you should probably just stick to using a string, at least at your first go-around, and then as you learn more about the data that will go into that column through kind of the learning process, you may find that, hey, that's not really a good choice, or here's a better data type that actually gives me maybe more functionality. And then the last thing is copyright, and actually I put down integer, but then as I started scraping stuff off of Amazon, I realized that that should actually be a date time type. So you're going to see me go off the cuff here for a minute. I'm going to actually jump into my PowerPoint, and I'm going to change that to date time. Alright, so can't say that I didn't have a current, up-to-date, and accurate PowerPoint presentation. Alright, so date, time, type. Now over to the far right, we have basically whether or not this field in our table is required, and this is about data integrity. So if you have books in here, you're always going to want to make sure that there's an ID column or an ID value in that database table, so that's obviously required. All books have titles. If the book doesn't have a title, there's really a big problem there, so that field should be required. Think of it from a data entry perspective. If somebody's coming back and they're inputting data into the system, you want to make sure that they're inputting a title into the table, and if they don't put a title into the text box for that data entry and someone hits submit and it tries to get written to your table, do you really want to allow that record to be put into the table without a title? So data integrity, we need titles on our books. That's a required column. Authors, same way. ISBN, I'm not that familiar with the publishing system, but I'm pretty sure that's part of getting a book published is actually going to, I think it's the Library of Congress, and having them issue you an ISBN number. Page count, it's required, it's a number. If you're writing and selling a book that has no pages, I mean, whatever, that's your thing, but you're still going to have 0 pages, so that book will have 0 pages, so that book will have a number of pages to be represented. Dewey Decimal, I don't know. I went on to Amazon, I looked up just kind of a bunch of like top children's books for right now, and they did not have Dewey Decimal numbers listed. I'm sure there's a way to store those and put those in. I'm not sure what process you have to go through in identifying a Dewey Decimal number for a book. It may be kind of an iterative process where you don't do it right away. So I set it as no. That was a decision I made later after I kind of started looking into book data. Since we are building a piece of software within the context of a library, maybe it makes sense to make it required. So those are kind of decisions that you have to make through the design process of, should it be required, should it not be required, and you kind of have to, fight those battles internally and decide, is it really make sense for it to be required or not. And we may go back by the end of this lecture and say, hey, we do need to make that a required field. Publisher is optional. It's a nice to have, but not necessarily required. Every book does have a publisher, but not having the publisher doesn't really make or break it. Topics, much the same way. They'd be nice to have, but not necessarily required. And the copyright information in the same vein of thinking that it's not necessarily required, but it's definitely a nice to have. So we've got it in there, but not as a required field. So we go through this and we create this kind of data structure for our table, and then just to kind of revisit this is what we would expect to see in an actual database kind of select statement. We run a select all from books, and we would see kind of this representation. Again, this is just in a presentation slide. It's not actually a real SQL table at this point, but we would have the ID, we'd have the title of the book, the author, ISBN, page count, and then Dewey Decimal is not required, so I've left it null because I couldn't find them on Amazon. The publisher of the book, the topics, again, is empty, and then the copyright information. So that's kind of the flow or the process that we would go through from getting from point A with, conceptually, what does a book have, all next to then let's take those concepts and actually build them into a database table.